Hi everyone. Today we're going to study Tower of Hanoi problem. There is a tower of n disk stacked in decreasing size on one of three pegs. The object of the exercise is to move the disk onto a different peg, obeying the rules. Number one, only one disk can be moved at a time. Second rule, no disk may be placed on a peg with a smaller disk beneath it. How many moves are needed to move all the disks onto a different peg? Let us see this example. We have three disks on the pegs A, B, and C respectively. All the disks are on peg A. We can see that the disks are of decreasing size. So step 1, we will move the smallest disk, the green one, into peg C. Then step 2, the blue disk we will put in peg B. Step 3, the smallest disk that is green we will put on top of the blue one in peg B. Next, this biggest disk from A we will put in peg C. And then, next move, the smallest disk that is green we will place in peg A. On the sixth move, we are going to put this blue disk on top of the disk in C. So, we have like this. And the seventh move, the smallest disk we will put on peg C. Now, the problem is solved. We can see that for 3 disks, we need 7 moves to complete the problem of Tower of Hanoi. For a tower of n disks, it takes 2 raised to n minus 1 moves. Now let us set up a recurrence rule. Let T of n be the number of moves needed to transfer n disk from one peg to another. Clearly, we have T of 0 equals 0, T of 1 equals 1, T of 2 equals 3, T of 3 equals 7. This is our example a while ago. We note that in order to move a tower of n disks, we need to do the following. Number 1, move the tower of n minus 1 disk from off the top of the nth disk onto another of the pegs. Step 2, move the nth disk to the destination peg. Number 3, move the tower of n minus 1 disk from where it was put temporarily onto the top of the nth disk. It is clear that steps 1 and 3 above each take T of n minus 1 moves, while step 2 takes 1 move. Hence, we have T of n is less than or equal to 2 times T of n minus 1, then plus 1. Consider that at some point, we need to move disk n. When we do this, we must have moved the n minus 1 disk above it onto a vacant peg. That must have taken T of n minus 1 moves to do, whatever T of n minus 1 happens to be. Having moved that final disk for the first and hopefully last time, we then need to transfer the n minus 1 smaller disk, which all need to be on a single peg. Otherwise, there won't be a spare peg to move disk n back onto disk n. This also takes t of n minus 1 moves to do. Now we see that there is not a better way to move the disk. That is, t of n is greater or equal to 2 times t of n minus 1, then plus 1. Thus, we arrive at our recurrence rule. T of n equals 2 times t of n minus 1, then plus 1. Now let us prove that t of n equals 2 raised to n minus 1. By mathematical induction, the basic step is show that t of 0 is true. Using the formula, t of 0 equals 2 raised to 0 minus 1. 2 raised to 0 is 1, then minus 1 is 0. If we want, we can also write t of 1. This is equal to 2 raised to 1, then minus 1. 2 raised to 1 is 2. 2 minus 1 is 1. Then we go to induction step. We assume that t of k equals 2 raised to k, then minus 1 is true. Then show that t of k plus 1 equals 2 raised to k plus 1, then minus 1 is true. By recurrence rule, it follows that the t of k plus 1 equals 2 times t of k plus 1. This t of k, the value is here. We substitute the corresponding value. Then this constant 2, we will multiply to each of the terms inside the grouping symbol. So we have now 2 times 2 raised to k. Then 2 times negative 1 is negative 2. Then we copy plus 1. This 2 times 2 raised to k, we can simplify and combine into 2 that is raised to k plus 1. And this negative 2 plus 1, we simplify as negative 1. And we are able to show that the t of k plus 1 equals 2 raised to k plus 1, then minus 1. Therefore, the t of n equals 2 raised to n, then minus 1.